Welcome everyone. In this video, we are going to learn about two searching algorithms. One is linear search and one is binary search. So in this particular video, we are going to discuss only about linear search. So here I have already given the complexity of linear search. If you see, in linear search, the best case complexity is big O of 1, where the element is found at the first place. So if suppose you are having 5 elements and the element that you want to search is present in the first location, so how many key operations you will perform to find out the element? Only one, because it is present in the first place. So this is the best case complexity. That can be the best case, that the element you want to search is present in the first location. Now what is the worst case? The element that you want to search is present in the last element, or it is not at all present in the array. Then you will have to go through all the elements. Suppose n elements are there in the array, you will have to search all the n elements. So in that case, the worst case complexity is big O of n. Okay, so these are the two complexities. One is best case and another one is worst case. Similarly, we have got binary search, but we are not going to discuss binary search today. Now let us see the algorithm for linear search. So this is the algorithm for linear search. Here, first of all, suppose data is a linear array, item is the element to be searched, and let LOC be the location where the element is found. So first of all, we are going to put the element, the item that you want to search, in the last location, data n+1. Suppose n elements are present. Then we are going to do set LOC equal to 1, that is location equal to 1. Repeat while data at LOC is not equal to item, set LOC equal to LOC plus 1. If LOC equal to n plus 1, then set LOC equal to 0. Suppose the element is not found, then we are going to make LOC equal to 0 and exit. So this is the algorithm for linear search. Now the same algorithm we are going to do we are going to write down the code for this particular algorithm. So let's go to devc++. What we are going to do, we are going to perform linear search. So first of all, let's write hash include stdio.h. Now what will be the output of this program? It is very simple, like enter array size. So here I will show you a little bit of concept of array also. Suppose 4, so enter elements. So you'll be entering 4 elements. Let it be, I'm just randomly entering some numbers. Now enter the element to search. Suppose you want to search 2. Okay, so you will write down element is present in location 3, third location, or location 3, whatever you say. So this is your program. So this is what you need to do using linear search. Okay, linear search is nothing but we are going to start from the first element and we are going to keep searching the array one by one till we find out the element. Okay, that is searching the elements linearly one by one. So write down main. Now since array is involved, so we will need one array. Let it be a of, just give some random size, and you will be entering array size. So for that, one more variable. Since we are using array, we'll be needing for loop for that I, and to element to search, you want the element to search, for that one, that item be the element to be searched, and one more variable LOC for the location, to give the position where you have found out the element. Now we are going to write this line. So we are going to write printf enter array size scanf %d comma ampersand n. Now you are going to enter the array elements. So you just write down enter elements. We will be entering elements, so we will have to give for loop I equal to 0, I less than n, I plus plus, because we are going to enter n elements, scanf %d comma ampersand a of I. That's it. Okay, now the task is to search the element one by one and find where the element to be searched is present. Okay, now next line is to enter the element to search. So you write down printf, enter the element to search. Okay, so scanf %d comma ampersand item. Okay, now we will be entering the array and check each element of the array with whether it is equal to item or not. So for entering the array, again I'll have to write I equal to 0, I less than I plus n, I plus plus. Now if a of I is equal to which item? Item. So if this is equal, that is if we find a number, then we are going to put the LOC as I plus 1. Why we are going to give it I plus 1? Because we are starting from 0, but if the element is present in the first location, suppose, we are not going to say that this present in the position 0. We will be saying it is present in location 1. That's why we are incrementing it by 1. Now suppose element is not present, then what we will do? So suppose element is not present and LOC value will remain what we give here. So let us give some value which is not possible at all, let it be minus. Okay, so at last we can say if LOC is equal to minus 1. If element is not present, then we are not going to update the location of LOC, value of LOC, so it will remain minus 1. So if that is true, then what we are going to write? Printf element not found. Okay, else if we get the element, then where is it is present? It is present in the location, right? So element found in location %d. So what is the location? LOC. Okay, that's it. So hopefully it will work. So delete this part, save it, give some name, and then just run it. Okay, so enter the array size, suppose 4, so 1 2 3 5. Enter the element to search, suppose 3. So element is found in location 3. Now let us run it again and try to see, enter a number which is not present. Okay, 1 2 3 4, suppose 9. So it is coming element not found. So this is all about linear search. Thank you.